right, so I'm going to go through this a little bit more rapidly than last time because I told you it wasn't recorded. So at least we have something on record. This was a polynomial. You're supposed to find the roots using synthetic division. I'm going to make the polynomials a little bit more complicated as we move on. Like I said, we have time, so we can play with these things and get to learn them a little bit better. But at the beginning, it turns out that most of these just have one root. So your first step is to graph this on a calculator. Today, we're going to spend time in class working with the calculators and making sure that you're able to do at least punch these things out. You can't go dry. Quayma knows I threw a tizzy fit in there. You haven't seen me get really mad. I was about to. You can't just walk in dry and not have used the calculator before. It's just too hard and there's too many weird things. You know, you'll get an error showing up. You won't know what the error is. So don't do that dry. Make sure you practice with it on the test. So this is an online graphing calculator, which is similar to your TI calculator. And I graphed it like I showed you the other day. The problem with the graph, and it looks worse on your calculator than it does on the online one because I have white space, but you have gray space. So it kind of looks, the graph that you get is dark gray and the background is light gray, and it looks kind of tiny in there. But there's a lot of white space here. You really want to look at where it crosses the x-axis. So you really would like to zero down here. If you look at the x values, that's around x equals 0 to 2. So if I made a little rectangle and a visual rectangle for myself, I want to zoom down into that location. You have a zoom in button on your calculator, but the zoom in button just keeps going down to wherever the center used to be. You would like to kind of go to the right a little bit and then zoom in there. So that's why I'm asking you to go to the windows. There's a button called Windows, and you can change the windows so you can go right and target right where you need to look at. So the windows I chose were 0 to 2 because the x values go kind of in my rectangle, go from 0 to 2. So you can't make that red rectangle on your calculator. You have to use bobby pins and then go like that and just see it. So see up at the top, I saved my windows. You can see I put 0 to 10. I didn't change the y windows. I never change the y windows unless the graph disappears or there is no graph. Then I know something's wrong. So then I make the y windows go exactly like the top and bottom of the rectangle. But so far so good. I can kind of see where this root is. It looks like it's around a third of the way from 1 to 2. So 1 1/3. That's what I would guess. But I don't need to really guess. I can use a trace button. There's a button on your calculator called trace, and you can just follow it actually shows up as a little cursor, which is a dark gray blinker on top of your dark gray graph. So it's kind of hard to see at first. It blinks though, that's how you see it. Kind of like a heartbeat on a ultrasound. If you haven't seen that, it's really cool. So I guessed, I got something like 1.3, and I guessed that it was about 4/3 or 1 1/3 because it's a textbook problem. So that tells me what my root is. It's 4/3. I already know the answer.
But how did you get 4/3?
I just saw that on the calculator it said 1.30 when I took the trace button.
Yeah. So then how did you get 4/3?
Because textbooks never have 1.30 something. It's probably 1.3333, right? It's probably 1 1/3. Right?
Yeah.
I just guessed. And it's a pretty good guess, but I don't have to guess. I can check. I can check it, right? I don't have to really guess. I can plug in 4/3 in there and see if it works. And guess what? I got 0.
So what if it doesn't work?
It's very unlikely. I've seen Webassign problems now for several years, and it's unlikely.
Could you plug in the 1 1/3?
I did.
I mean, like, as 1
Don't.
1/3.
Always use the, what do you call them? Use the improper factors. In college, we never use mixed fractions. Never. We just don't, and
So on the test, if I just do 1.3, is that okay?
well, it won't be the root. It won't make it exactly 0, and all your calculations after that will be messed up.
So then how do I just complete all the 3 tests? My question
Practice. You practice.
So you just keep trying them.
Well, when you put it on the trace button, it's not exactly 1.3. It says 1.3 with a bunch of garbage after it. So it's not exactly 1.3. But, so you know it's got to be around 1.3. What's your best guess? It will? There might be a way that you can do it on the calculator when you guys play around with it. Did you ever get a new phone and you were used to your old phone and you got the new phone and all of a sudden you didn't know how to like do things on it? Did you ever say, well, I don't know how to do things on this thing, I'm just going to put it in a drawer and put it away? No, because the phone's useful, right? So it's the same way. The calculator's super useful. It's $150, or you guys got it for a lot cheaper than I did, but whatever, it's expensive. You can use it to actually solve these problems, and it's going to save you a lot of grief. It's going to require you to play around with it. I got to give a talk right after this. Don't make me lose my voice. Hello? Yeah, that's what I did. It's like mine was like 1.30 something. So I just took my best guess. From my experience with textbooks, they don't have an answer like 1.3 something. They usually have 1 1/3. Right? Okay, so you can just check. That you asked me, how do you know that 1.3 is not the answer? Well, if you put 1.3 in here, you're not going to get exactly 0 when you crank it out. You should get something close to 0. If you don't get something close to 0, because 1.3 should be close to the answer, you got it off the trace button, for heaven's sake. It should be close. So if it's way off, something's wrong. Either you're not typing things into the calculator correctly or something's off. It's just like when you get the new cell phone. You got to play around with it a little bit. But just like the cell phone, you don't have to keep playing around with it, although some of us still do. I do too. I'm guilty. Don't come by any meeting that I'm having, because then you'll see me in there playing with the calculator. And then you'll say, you told us not to play with the calculator, and you're playing with the calculator. And I just said that on YouTube. That's really good. So, I mean, you just have to play around with it, but it's not like it's a startup cost. Once you know how to use it, you know how to use it. You'll be in your calc class and you'll be using it. And you'll be showing other people. Oh, you don't know how to do that? Let me show you how to do that. It's easy. You'll be helping everybody else next time. Okay, so synthetic division. I know my short thing. It's 4/3. It goes in the box. These guys over here, the 3, 2, minus 8, are the coefficients of the polynomial. Guys, they're the coefficients of the polynomial. 3 comes down. Then I take that 3 in the 4/3 and I multiply it. Goes up here. I add 2 to it. I get 6. Because 4/3 times 3 is 4. And then if I add 4 plus 2, I get 6. Do it again. 6 times 4/3. This is the same problem I did the other day. I'm doing it quickly because I didn't get the recording. I get a 6 down there again. 6 times 4/3, I get 0. How do I know I did it right? I'm supposed to get a 0 at the end. Right? The calculator won't lie to you. It's going to give you the right answer. So if you don't get a 0 at the end, it's arithmetic error. So that's another way to hunt your mistakes down.
But we can't just plug it into the calculator.
As your final answer?
No, to get 0. Can we just plug it in?
Well, there might be more roots. So the thing is that this thing that you have left over, it might be factorable. You don't know that yet. So you have to take it to the next step. This one only crossed one place, so I know it has only one root. You do get the full answer from it, but you can't use that. The point of this problem is not to get the answer, because you can get the answer so easily. The point of this problem is to teach you how to use the calculator, to teach you. I'm skipping all the stuff on graphing. I don't have to. I'd rather have it be useful for you. You learn how to do graphs at the same time that you're doing this. So that's the approach that I've taken, and I want something sustainable. So you get into the next class and you can find it useful. So when you're asked to graph something or you're asked to do synthetic division, I wouldn't just pull it off of the calculator and give that as the answer, because A, you're going to get maybe get a professor who thinks you cheated. You don't want that. They'll ask for your work, right? and then you'll be in the hot spot trying to say, I did it on the calculator. Then their next step might be, I'm going to ban all calculators in the class. You don't want that either. So always put your work down, but always check it with a calculator and make sure. If you know the answer first, it's kind of easy to get the rest of it.
How did you do the first with the 3?
It just comes out. This is the process, right? This is it. So how do I write the factors out? So x minus 4/3 is one of the factors because I know 4/3 is a root. Then I have all the coefficients down here. The 3 and the 6 and the 6 become the coefficients of what's left. 3, 6, and 6. How do I know it's 3x squared? Well, because I started out with an x cubed. So the next time around, I'm going to get an x squared. If I did synthetic division to this thing again and I actually got it to work down smaller, the next go round would be an x to the 1. But I'm not going to get smaller, right? Because I already know there's only one answer, and that's x equals 4/3. So I know from my graph already there are no more factors. Just to see, well, what happens? I could take this and set that piece equal to 0 and see what happens. And what I get is a negative under the square root. See what happened? If I did a quadratic formula, I get this thing right here. I'm going to actually have him carry it all the way through so you can see that. So I'm not going to get it anymore. I have a wonderful story. I was at a undergraduate research thing for math, and somebody asked me to find some huge series, infinite series. I ran it on a computer. He didn't say how to do it, so I put it on a computer and I ran code. And I came back and I said, the answer is 3x plus 5. He said, how did you get that? Where's your work? And I said, I don't have work. I ran code on the computer and it told me the answer is 3x plus 5. And he's like, that's not, I need to see the work. He wouldn't let me get away with that. And I felt like I really understood the problem because I went in and actually had to program it. But he was always suspicious of me after that. He'd always look over at me, and no matter what problem he asked, he'd go, no computers, no computers. He didn't know what the computer could do or couldn't do after that point. So it's a good thing to know that if they're asking you a question, answer it the way they want to, but use that calculator to give you the answer, because why wouldn't you? You're going to find it takes a few seconds to do this. Right, I'm going to give you an in-class assignment today so you can see how I ask the question. I ask you for all the pieces. I ask you to do the stuff on the calculator, to even change your windows. I ask you to do that and graph what you see so that you learn how to use the calculator. You learn what graphs are really about. And it's not artificial. You actually can see the changes as you're putting stuff into the calculator. And then you do the math and you can see the connection between the whole thing. And I'm doing that because I've seen that it's sustainable. It works in the next class. It's useful for you. You already parked here. Might as well make it useful. All right, so this is where we're at. We only have one root. It's x equals 4/3. Okay, any questions? So I'm going to post this PowerPoint up here online so you can see the rest of it. This is another one. I gave you a couple of these to do on the Webassign so that you can practice using your calculator and getting used to it. You should always be able to get the right answer with the calculator. Maybe the first thing you want to do is just type in the answer that you get on the calculator into Webassign and see if it matches up. Then you'll know that you're doing it right. Same process. I showed you this yesterday. Oh, I showed you that yesterday too. Oh, your favorite, difference quotient. All right, this is a difference quotient problem. Same rules. Difference quotient is what you first start out with in calculus. Calculus is about slopes of curves. So you did slopes of lines all your life. Now you're going to do slopes of curves. And you're actually calculating the slope between two nearby points. So that difference quotient is really a change in the y values over the change in the x values, which is whatever the h is. That's how much x has changed. I'm going to show you some pictures and give you a little introduction to calculus at the end of the semester so that you have just a little bit. Then there's going to be summer break in between spring semester and the fall, and you forget all about me. No, actually, somebody said that they were able to go back to the YouTube videos, so then you can go back. All right, so the process is still the same. You calculate f of x plus h. Notice that at the very top, I put x plus h wherever there were x's, and notice my parentheses. On the exam, I will have cut points for not having parentheses. It's like the single most bane of calculus existence, not having your parentheses, and everything's messed up after. So make sure you put your parentheses. You can look at the rubric on the side. It'll say, forgot parentheses, blah, blah, blah. So you'll know to go back and put the parentheses. So notice right there, instead of minus x, I have minus x plus h in parentheses. Right over here, f of x minus f of x plus h minus f of x, which is the next step in the difference quotient. I have subtracting f of x in parentheses. It's important because when you take off the parentheses, what happens to the signs?
They don't change.
They change when it's a minus sign in front. Right, they all change in there. And so there they are, they all change. So f of x plus h minus f of x is this huge mess up here, divided by h here. And I started doing some stuff here. Like, I know that I can split these up. I was looking for ways to simplify it. I don't think I can simplify it any further. I did one thing extra.
Is that an H?
Mm-hmm.
Is that an H or an H?
Which one?
The last one is the F of parentheses X plus H minus F of.
It's minus x. See, right here I just took out the parentheses.
No, over. Go over there.
It's just a copy of this. F of x.
Okay.
Right, it's this.
Okay.
Difference quotient.
For the blue part, the second e to the negative x, is that you multiplying that? Or is it just on?
There's no multiple. These two laws of exponents.
Oh, okay, there we go.
It's hard to explain how this all works. Like, you learn it in little pieces, and when you're in a pre-calc course, here's how you do a cosine, stuff with cosine, and here's how you do the polynomial stuff, and here, and they're all separate. And all of a sudden, you go into a calc class, and you're supposed to do a lot of stuff with it, like I'm doing. I'm just autopilot going, oh, now I can do my laws of exponents. I have it all integrated. And that's like when you first, I don't know if you've ever watched anyone learn basketball. The first thing they do is you try to teach them to dribble. And they'll always travel with the ball. If anybody knows how to play basketball, it really bothers the person watching them, because watching someone travel it's awful. It's like dividing by zero. It's a horrible thing for someone to do. So you watch them struggle through that. But after a while, when someone plays for a while, they won't even walk with the basketball to the court. You'll see them dribbling. It's a second nature kind of thing. So that's what's happening to me here. I'm dribbling. So what can I do there? Well, maybe I can do a little factoring. So what I did is I grouped these two guys together, and I factored out an e to the x to the left. It's not going to help me. That's why I wasn't very keen on this. And I took an e to the minus x out of the left here. E to the minus x times e to the minus h. This first term, e to the minus x times minus 1 is this second term. So I just grouped the first and third term together, and I grouped the second and the fourth term together. It doesn't get me anywhere. Nothing cancels. Like usually with these, when you have these problems, something cancels, nothing cancels. So I'm not sure what Webassign's going to do, because I don't think I copied the answer here. But I'm going to guess that you could even plug in this version right here into Webassign, and it should take it, because there's nothing canceled. You notice that.
So the black stuff. So that was the answer. The black.
Right. That's what I just got done telling you. I don't know what Webassign's going to take, the blue or the black. There's nothing canceled, so nothing changed.
On the test, you want to be in that form with the parentheses on the bottom? With the black? Like that's
No, unless it'll say on the rubric. You'll see it.
So will there ever be a case with the E where it cancels and stuff?
Yes, usually stuff cancels when you do these difference quotients. If you've done enough of them, that's why I was trying to do stuff. I thought something would cancel. I know what the next step is, but I don't see any. It's not going to really move anywhere.
Do we take a final in this class?
Yeah, absolutely.
After this one, the other one?
Yeah, you take a final in here.
After this exam, the other exam?
There's a third exam and there's a final. Final should be the easiest thing in the world because the third exam's almost, yeah, absolutely, you have to take it. This is what I call content course. You have to walk away with content. You're not learning a skill, you're learning content. So not only am I giving you a final, I'm trying to make sure that you're wrapping everything together every time.
So if you do bad, you can mark that grade.
The final? No. The final is 40% of your grade. You have to be able to walk out of here and know that you can do those things.
And what's
I don't remember those things. You have to go to the syllabus. I'm going to forget to video something because stop. All right, this is an old problem. I brought it back again. You're given sine x and you're given cosine y and you're asked to find sine of x plus y. So those are the two pieces of information that you have. There's a formula, and there's the formula. It's called sum of angles formula. Before you guys ask me, I'm going to give you the formula on the test, but I'm going to give you a lot of formulas on the test. You have to know which one to pick. So this is the formula you pick because they ask you the question about what is sine of x plus y. That's why you know to pick this particular formula. What do I have given? Those two boxes I have given. So I'm going to substitute them. Sine x is 1/2. I'm going to drop that in. I'm going to erase the sine x and I'm going to put 1/2 in its place. Cosine y is given to me. It's minus 2/3. So I'm going to erase the cosine y and replace it with minus 2/3, like so. Yep. So that. Well, I'm not a big deal. So we got some hard stuff coming. So now I have to fill in those other two pieces. What's cosine x and what's sine y? So I have to find cosine x. That's my first objective. I know sine x. It's minus 1/2. I've got to get cosine x. So I'm going to use the famous identity. You're cosine x and I'm sine squared x, and together we make 1. There we go. You can use it for Valentine's Day next year. Cosine squared plus sine squared is 1. Well, I know that sine squared is 1/2 squared. I didn't put the minus because minus and squaring a minus is the same thing as squaring a plus. So I left it out. But I can now solve for cosine squared. Cosine squared x plus 1/4, that's 1/2 squared, is equal to 1. Solve for cosine squared, you get 1 minus 1/4, which is 3/4. And how do I get the cosine by itself? Square root both sides. So cosine x is plus or minus square root of 3/4, which is the same thing as plus or minus square root of 3 divided by 2. Now, I don't get a plus or a minus because they gave me another piece of information at the top. They said it's in the second quadrant. In the second quadrant, cosine is less than 0. So I drop off, I don't need the negative, I don't need the positive one, I only have the negative one, which I wrote in yellow.
Why is it plus or minus?
Because when you square something, the negative square could have given you the same answer, like minus 2 squared gives you 4, and positive 2 squared, so it's not a 1-to-1. You have two answers when you go back down the other way.
Okay.
Does that make sense? I like to see it graphically. I don't know, and I'm not a graphical person, so I'm surprised I'd like to see it this way. But so let's just look at a parabola. If I want to know where this parabola is equal to 1, here's y equals 1. Where does y equals 1 intersect that parabola? It does in two places, here and here. That's because minus 1 squared gave you 1, and positive 1 squared gave you 1 too. So you're going backwards and asking where did, if I have x squared is equal to 1, where did it come from? It could have come from either one of these two places. So I have two answers.
Thank you.
Does that make sense?
Yeah, it did.
What's the yellow one? I'm really confused by that.
It's a square root. I just kept the negative square root of 3 over 2. Should be 3 over 2, not 3 over 2.
That's the second
Good,
part.
because I made a mistake.
That's what, yeah.
Minus square root of 3 over 2.
The second part, and it's supposed to be -1 over 3.
Negative one.
Well, you cancel 2 and 2.
Yeah, I'm not there yet. I'm still looking for this.
Oh, so you just left that one?
Yeah, I don't care, it's just numbers.
Can I see what it says on the yellow?
It's negative square root of 3 over 2. I just keep the negative of this one,
Okay.
right? Because I already know that it's in the second quadrant. So I got two answers. Which one's the right one? It's going to be negative square root of 3 over 2, not positive. Because I'm in the second quadrant and cosine is negative. So that's the yellow. The yellow was negative square root of 3 over 2.
Oh, I didn't know. Oh, wait, it's a different one.
What?
I was gonna ask why I know it's in the second quadrant.
Yeah, they gave it to me. So I know that answer. And notice that I changed the sign there. So I plugged it in. And I plugged in the wrong thing. Square root of 3 over 2, not square root of 3 over 4. Let's just cover that up.
So that's the sign. So we found the sign out of the cosine.
We just found the cosine. We still got to get rid of the sign.
This was you got this last week, right?
Yeah, I did. I'm doing it again.
This is what I put this in.
Yeah, same here. I thought this was in the that's so much. Do you keep it as plus?
No, it should be minus. Let me see if I can do this. No, it won't let me.
Why is the
Okay, so this is how I typed in the correction. Minus square root of 3 over 2. I kept the negative, goes in for the cosine. Now I have to find the sine y. I go through the exact same process to find the sine y. I'm given that cosine y is minus 2/3. I'm going to use the famous identity with y's in it instead of x's. So let me move on to the next slide, and we're going to copy and paste this stuff. If it'll let me. Okay, so now the job is to find sine y. I'm going to make this change after the fact so that I can just move on and show you how to find sine y. I know that sine squared plus cosine squared is equal to 1, even if the angle is a different name. So before the angle was x, now the angle is y. That didn't make a difference. That confused the previous pre-calc class quite a bit, because they got confused with x's and y's and sines of x's and cosines of y's, but it's still the same formula. So sine squared matched plus cosine squared matched is equal to 1. It doesn't matter what you put inside there. It's always true. All right, so what am I given? I'm given that cosine y is minus 2/3. So I'm going to put minus 2/3 in for the cosine y, and I'm going to go through the same business I just went and solve for that sine y. It turns out that that sine y, after I go through all the square root business, well, in the second quadrant, sine is always positive. So in this case, I keep the positive term. I get sine at y is equal to square root of 5/3, and I replace that sine y with square root of 5/3. And I'm also going to, right now, come back to the other page and make that other correction. Oh, it did let me do it all. All right, so there I'm at. Now, you guys wanted so badly to cross out those 2's. I can do that whenever I want. And I just do that at the end. It's a correction. Remember, I didn't have the right sign on it, and I had a 4 on the bottom. That was like 5 slides ago.
So you just multiply straight
I
across.
know that you just combined everything, but like, what was sine y? Can I see the word real quick, please?
One slide back. Sine y was square root of 5/3.
Where did the 3 come from?
What?
Where did the 3 come from? Didn't you change?
There was an error. The yellow stuff was an error.
Wouldn't the answer be over 6? Yeah, because it's radical 3/2.
She left it at the 4.
Yes, correct.
I see what you're right. Can you please? It confused me.
If I go back a slide, that's going to have the error in it. So don't ask me again about the gray things. I can't keep copying and pasting the gray things. So the correct answer, which was written correctly, but somehow the second time I wrote it incorrectly. We call that a transposition error. So this answer I got correct. For some reason, even though I got the answer correct, I wrote down plus square root of 3/4. I wrote down something completely different. Probably snow day, probably somebody was at home and asking me questions while I'm doing this.
Isn't the square root of 13/6 equal to negative?
Yes.
Fix everything and watch the video.
I can't do that. I don't have time to do the video again. If I had time to do the lecture again, that would be great. Say it again?
Say like post at like all like gray boxes and just watch the video.
There, the gray boxes are posted. This is the video. I don't do a separate video.
Where's the negative 1 come from?
Oh, just negative.
You want to just next question.
Where did the gray box come from? Is that the next question?
No, next question.
Oh, I did the negative one again.
Next problem.
There is no next problem. That was the last one.
Oh.
Would that be the answer?
Yes, -1/2 minus square root of 15/6.
This is my problem. Did the negative come from?
What's the answer? Press that, is it negative 1/3, subtract 5, what's 18?
No, because square root of 5 times square root of 3 is square root of 15.
So that's square root of 15. Oh, sorry.
Did the negative come from the 2?
Yeah, this negative doesn't come from the 2. It was always there.
And then again, because so that's the answer?
This is the answer. All right, let me back that
It
up.
has it negative 1/2. That was a negative 1/3.
It's negative 1/3. She's asking about where the negative came from. It came from the second term. It's a negative 1/3 in front.
What did you guess? 6?
6 is 2 times 3.
No, I know we do 2 times 9, 18, because we're multiplying the
Your question?
So we have the values for the sine x and y. It says find the values of sine x plus y.
Right. I have it. I'm using a formula. Sine x plus y is this.
So we just include the values, not the actual value. I thought that it would be translated to like something.
I can't hear his question.
I thought that like when we finally get it, we translate it to like pi over 6 or pi over 3 or
No. I mean, you can make this a decimal, but Webassign won't accept it. Right? You need the exact answer. This is a number, right? This is a valid number. It's just not a pretty number. Okay. Guys, shh. No, the sine y is not negative in that quadrant. It's positive. So this term only, this was the cosine x. It's negative. This was the sine y. It's positive.
Could you go back to like the formula with the sine x plus y?
Absolutely. In fact, let me pass out your in-class assignment. You see these formulas sitting in straight in the front.
Thank you.
It's called sum of angle formulas. Now, who asked me if do they want to see the sine y business again? Here we go. Let me back it up one more. Okay, let me look. She asked a question. She's waited. She asked a question. She waited for everyone else to keep asking questions over her, and now she's patiently waiting. Very polite. All right, sine y squared is cosine squared is equal to 1. Okay, and that doesn't matter if I change the inside. You know, this could be x's in the inside. This always holds no matter what's in the inside, as long as these two angles are the same. Wait, I'm given cosine y. It's minus 2/3. So minus 2/3 can come into that cosine y. Goes in there. When I square minus 2/3, I get 4/9. So sine y squared plus 4/9 is 1. Subtract the 4/9 from both sides. Right. And then square root both sides. But you're going to get plus and minus when you square root, for the reason I drew with the parabola up there before. But I'm told I'm in the second quadrant. So up at the top, you're told that your thing is in the second quadrant. The second quadrant, sine is always positive, because you draw that unit circle almost on every quiz or test that you've been on so far. So you know that. What do you think?
Yeah.
Probably right.
On the review sheet, right? You know all
This is
those
not a review sheet. At the top. It's not a review sheet.
class assignment.
It's only a few problems, and it was just problems people asked me questions on.
Okay. No, like the half for, we just have to do the first one, right?
I give you that whole list. You pick. So that's Let me hold up a little bit. Is it clear what's going on here? Finished answering your question. Okay. All right. You had a question too, Michael.
Are we handing this in today?
Yes, it's an in-class assignment.
Okay.
So this is not a review sheet. It's not comprehensive in any way. I just picked some problems that I thought people would need to practice on, especially that you could work on in groups where, kind of like I saw her answering a question over there. So working in a group will help you iron out some of the confusion that you might be having. So that's why I have it.
You have action ones, so like I can do this at home too. Do it again.
I'll post it online.
Oh, okay, cool.
You just have to remind me if it's not there,
All right.
right? Because I think up till now the 7, I have classes and meetings. Then I drive home and I listen to metal on the way, and then get in the door and I have kids clawing at me, and I start to forget everything.
Thank you.
If it's like addition, like why do we at the end multiply everything?
There's no multiplication at the end.
She means multiplication right here. You know how you
Yes, I'm going back to the formula. The formula has multiplication in it, multiplying terms, and you're adding 2 to them. So I'm figuring out what that is, I'm figuring out what that is, I'm figuring out what that is, I'm figuring out, and then I'm plopping them in there.
And then you just multiply first, multiply last, and then add those.
Right.
Okay.
Yeah, I'm just putting them into.
So y'all just trying to
get into groups and work. If you are not familiar with your calculator, start on that one first. That's a synthetic division problem. I also put on there, on problems that you haven't seen before, I put a sample rubric so you can see how I'm going to grade it, so that you won't be surprised when you see it on Monday. Can I? Video's not done.